This is 1.3, day 1, part 2. This is a rule for radicals. If you have a radical, you can split up this radical into two separate radicals if you have division. So sometimes that benefits you when you reduce down. On this slide, we have some examples. The first example, the square root of 144 over 25. This is one large radical. You can separate out this large radical into two separate radicals. Why this might help you is we can recognize that the square root of 144 is 12 and the square root of 25 is 5. This is 12 squared. This is 5 squared. And we're left with 12 over 5. Example B. Let's just watch. Don't need to write. Again, we have one large radical. We can separate it out into two separate radicals. Square root of 25 is 5. Square root of 36 is 6. All right, this example is a little different. Now we have two separate radicals. Sometimes it's better to put them back together into one radical. So let's see what happens. We have 500 over 5. Can you reduce 500 over 5? Yes. So just go ahead and divide 500 by 5. And you get 100. And the square root of 100 is 10. The reason why is 10 squared. Our index is 2. So our answer is 10. Sometimes it's better to combine them back together into one radical, and sometimes you split up into two separate radicals when you do division. All right. You don't need to write this down. What we're going to do is focus on how we might have to rationalize denominators. If you have a monomial, so that would be a denominator of just a single radical, you would rationalize it. If not, you would have to maybe use the complex conjugate. So that's what this piece is talking about here. All right, so example, please write it down. 1 over the square root of 3. It's not considered proper to have a radical in its denominator. So what we do is we rationalize it. So we look at the denominator. The denominator is the square root of 3. To rationalize it, here's our original 1 over the square root of 3. We multiply the numerator and the denominator by the square root of 3. And now we multiply across. 1 times the square root of 3 is 1 squared, so 3. And then if we remember, square root of 3 times square root of 3 is 3. So there's our answer. It's not necessary to have that 1 in front of the square root of 3 also. So let's try this one. 3 over the square root of 5. We are going to rationalize it by multiplying the numerator and denominator by the square root of 5. Now I multiply these two fractions across. So 3 times the square root of 5 over, and then square root of 5 times square root of 5 is square root of 25 or 5. This will be your assignment for 1.3 day 1. You'll be doing some simplifying, multiplying, and dividing.